From the British University in Dubai, Kawloud Byan will be presenting research study about designing a country house with passive strategies in the United States under the supervision of Dr. Hanan Talib.
Today we are going to present our introduction, aims and objectives, literature review, international case studies and selected case study, methodology, passive heating and cooling strategies, results and analysis, and finally conclusion.
As buildings contribute to approximately 40 to 50% of the overall carbon emissions in the United States, it is very important to implement passive heating and cooling strategies to achieve the most energy efficient way to heat and cool a home.
Our aims and objectives is to design a sustainable 4-bedrooms country house in the United States, assess the house using LEED specifications, and enhance the thermal performance of a country house using different passive heating and cooling strategies.
Different literature reviews have been reviewed to know more about the topic. A study done by Korn in 2020 resulted the weather is extremely cold and snowy winter along with the warm to hot summer. Another study by Sinha in 2020 resulted that the southern side of the building received the highest amount of the solar radiation, whereas the north side received the least. Another study in 2020 reported the dark color thermal mass shows an annual reduction by approximately 25% in heating requirement for building. Another study by Kaiser in 2015 found that the very important to carefully implementing very specific techniques for decreasing energy usage.
Kroger, Suzuki, and Matosky studied in the year 2013 the implementation of flexible dampers for windows and adjustable vents for walls, and showed that these processes can be applied to reduce climate risks. Kim studied in the year 2012 different shaded methods and showed that the experimental shading device at a solar altitude of 76% resulted in the highest energy saving of 11%. Hogas, Kalotet, and Ghani in the year 2012 studied different passive cooling techniques and showed that by incorporating evaporative cooling with wind towers, a temperature decrease of 12 to 15 degrees Celsius was observed. Montazri in the year 2010 studied two-sided wind tower and showed that the best performance was observed when the experiment was conducted at 90 degrees angle.
Different international case studies was studied.
The first case study is the Pissancourt home in France. The passive features that are used are shading element with bamboo wood panels.
Different case studies in New York. The first one is the St. Carmel residence. It used passive cooling strategies, shading element, balcony, and tilted roof. The second case study was the passive house, which used shading and PV panel in the roof. And the last case study was the Mamoronic passive house that used shading, PV panel, balcony, and tilted roof.
The modeling and simulation has been done using Open Studio software by developing building geometry, creating spaces, thermal zones, HVAC systems, calculating the building's energy consumption, analyzing the data to find the optimal energy-saving design solution.
Selected case study.
Case study is located in Buffalo, a city in the United States which lies in the western of New York. In New York, zoning strategy typically involves the division of land into various zones. The location of the country house is located in DR residential campus.
The amount of sunlight and the best direction of the sunbathing can also depend on the specific location and the time of year. It is important to consider the direction of the sun for optimal exposure.
In Buffalo, the weather is characterized as continental. It experiences extremely cold and snowy winters along with warm to hot summers. The wind is blowing from the northwest. On average annual percentage of humidity is 72%. Also in Buffalo, the longest day is 20 of June.
Access to the site and the nearest landmark. Planning and development are very important consideration because of their vital roles in navigations, accessibility, economic development, community identify, and general livability. About the access to the site, the rectangle in yellow color indicate the site. There are 4 sub-roads shown by a dashed line in the red and 1 main road shown by the dashed line in yellow.
The idea of the logo comes from the topography of the buildings in Buffalo City. The name Let the Eco House Shine comes from the idea of shining the spread of passive heating and cooling strategies all over the year. Bubble diagram shows how connecting the spaces is essential.
We have design units of different size and length to provide outdoor spaces and create a spirit of harmony between internal surrounding environment and the green spaces. In our design, we locate the surface to face the north and we open the largest amount of windows on the side facing the wind to attack the greatest amount. We place the animal in this direction to prevent their smell from entering the house as well as the car parking. We place the garden and swimming pool to the east to create an aesthetic view and harmony with the whole and enjoy their time.
The house is designed as a two-story, four-bedroom house. Upon entering the house, people are greeted by the spacious hall that connects to the various living areas. The ground floor contains a guest room, dining area, kitchen, and a maid room. Moving to the first floor, it consists of four bedrooms designed for privacy and comfort.
Design specifications. The land area is 1,825 square meter. Landscape area is 600 square meter. Building area is 892.48 square meter. Villa of two-story that contain 5 bedrooms. Each floor has a height of 4 meter. The construction material was concrete, solid and hollow block with a thin layer of insulation over the primer. For the indoor finishing material, lighted color ceramic with light paint color outside, with tilted roof and all the glazing double glazed windows with 30% reflection.
According to our house design, the building achieved 41 points, which means that the building is certified according to LEED.
After the modeling, we insert the weather data file. Then the different schedules have been designed according to the presence of the family members in the house. For example, the building occupant schedule shows that the all family members in the house during the night until 8 a.m., while from 9 a.m. to 5 p.m. most of them will be outside. All of the construction were according to Mid Apartment Ashri 169 2013 4AA construction.
The house has been constructed as two stories building and it was divided into two thermal zones. Annually, the cooling consumption was 6,028 kilowatt hour, the heating consumption 114,922 kilowatt hour, and the total energy 120,950 kilowatt hour.
The first strategy was the orientation. In order to reach the optimal building orientation, the building was simulated by orienting it in many angles, and the result showed that the zero-angle orientation achieved the optimal solution and shows the least energy consumption.
In this research, the effect of natural ventilation was studied by 3 scenarios. In the first scenario, all the windows were fixed. In the second scenario, 50% of the windows were operable with adding a solar chimney. In the third scenario, all the windows were operable to ensure the cross ventilation in the building. The results showed that the second and third scenarios were efficient in decreasing the cooling consumption comparing to the first scenario by 3.3% and 2.8%, while the heating consumption has been increased in the second and third scenarios.
Shading element strategy. Overhang system have been developed to moderate the effect of solar radiation. Annually, shading element decreased the cooling by 51% and total energy consumption by 2.3% compared to the base case. However, the annual heating consumption was increased 0.3% compared to the base case.
In this strategy, a courtyard was opened in the middle of the building and the area of the building in the first floor was reduced from the northwest side. The implementation of courtyard led to a reduction in the cooling 33.09%, in heating 9.38%, and total annual energy consumption reduction of 9.38% compared to the base case.
In the one-point tilted roof strategy, the roof of the building has been changed to the one-point tilted roof system. The implementation of the one-point tilted roof contributes to a reduction in the building annual cooling by 30%, heating by 3%, and total energy consumption by 22% compared to the base case.
In this strategy, the tilted roof was modified to be from one side higher than the other side to provide opening for ventilation. Ventilated roof strategy is very efficient in reducing the annual cooling, heating, and total consumption of the building by 30%, 21.84%, and 2.28%.
Side shading element strategy can be considered as a passive cooling strategy by providing seasonal tree and building around the house to study the effect of side shading elements. Side shading reduces the annual cooling by 14%, heating by 6%, and total energy consumption by 3%.
In this strategy, the building has been elevated above the ground and the floor was insulated by a typical insulation. Also, a wind tower was designed and opened above the staircase area to improve the ventilation and the air circulation in the house. This strategy reduced the annual cooling 26.59%, the heating 2.89%, and total energy by 14.06%.
In this strategy, a throne pole is positioned to receive direct sunlight through the thin layer glazing on the south-facing side of building. The throne pole was designed with a vent in the top and bottom to enhance the air circulation. This strategy reduced the annual cooling by 7%, heating by 4%, and the total energy consumption by 5%.
In this strategy, the roof, floor, and exterior walls were insulated, which resulted in decreasing the annual cooling by 5.72%, heating 10%, and total energy consumption 4.42% compared to the base case.
Combination of various passive heating and cooling strategies. In this strategy, we use many passive techniques: horizontal overhang shading, side shading, courtyard, ventilated roof, and solar chimney have been applied. This strategy reduced the annual cooling by 35%, heating by 13%, and the total energy by 11%.
Results and analysis.
Energy consumption result. In terms of the annual cooling energy consumption, the shading strategy is considered the best as it reduces the cooling energy consumption by 50% compared to the base case, followed by the combination strategy which reduces it by 35%, and the courtyard strategy which reduces it by 33%. One-point tilted roof and ventilated roof strategies were the most efficient way in reducing the annual heating consumption by 21%, followed by the elevated building strategy which reduced it by 13.5%.
It can be concluded that the ventilated roof and one-point roof strategies are the best in terms of reducing the annual total energy consumption by 22.3% and 22.2%, followed by the elevated building strategy which reduced it by 14%.
In terms of energy consumption, the result shows that the second and third scenario decreased the cooling consumption by 3.3% and 2.8% respectively compared to the first scenario. However, the heating consumption increased by 1.2% in the second scenario and 2% in the third scenario, which led to increase the total energy consumption.
In the first scenario, it can be realized that the zone ventilation values are near zero because all the windows were fixed, and this can be contributed to infiltration effects. In the second and third scenarios, the zone ventilation was around zero during winter, while it increases with the increase of temperature during summer. In scenario 2, the highest rate was in July, which is the hottest month of the year in Buffalo, as it reaches 80 meter cube over second, while in scenario 3, it was 170 meter cube over second. However, in scenario 3, the highest rate was in May, around 190 meter cube over second, while it was 77 meter cube over second in the same month in scenario 2.
In terms of zone ventilation temperature and humidity, the second and third scenario reduced the mean temperature by 1 degree in the thermal zone 2, while it kept the same in the thermal zone 1 compared to the scenario 1.
The results showed that all strategies were efficient in maintaining a zone mean air temperature between 16 degrees and 21 degrees during winter, while it was between 16 degrees and 25 degrees during summer.
We chose service 126 and we tested it through all the strategies that are used during 3 times at 9 a.m., 12 p.m. and 5 p.m. according to the coldest day, which is 3rd of February, the mildest day, which is 1st of May, and the hottest day, 7th of July. Conversion of surface zone mean radiant temperature. The results showed that during February, elevated building strategy experienced the least surface zone mean radiant temperature, while trompe wall was the most efficient in increasing the surface zone mean radiant temperature. During May, courtyard strategy experienced the least surface zone mean radiant temperature, while the thermal mass strategy was the most efficient in increasing the surface zone mean radiant temperature. During July, shading element strategy was the most efficient in decreasing the surface zone mean radiant temperature, while the thermal mass strategy gave the highest value.
The results showed that the combination of cooling and heating strategy resulted in the least mean temperature of 19.6 degrees and 19.8 degrees Celsius for thermal zones 1 and 2. However, ventilated roof strategy was very efficient in increasing the hours in which the temperature is more than 22 degrees Celsius compared to the base case. Moreover, ventilated roof strategy was most efficient in lowering the relative humidity in thermal zones 1 and 2.
The results showed that the ventilated roof and one-point roof strategies experienced the least heating consumption in February. However, the least cooling consumption in July has been achieved by the shading strategy.
It can be concluded that the ventilated roof strategy was the best strategy in terms of reducing the annual total energy consumption. According to our ventilated roof strategy house design, the building achieved 61 points, which means that the building achieved gold certification according to LEED.
It can be concluded that the shading strategy is considered the best as it reduces the cooling energy consumption by 50% compared to the base case. However, one-point tilted roof and ventilated roof strategies were the most efficient way in reducing the heating consumption by 21%. Regarding the annual total energy consumption, it noted that ventilated roof strategy is the best in terms of reducing the annual total energy consumption by 22%.
At the end, our recommendations can involve creation of new building materials with enhanced thermal properties. For example, phase change materials that can store and release heat efficiently could be integrated into building envelopes to improve thermal comfort. Advancements in smart materials and coatings may enable surfaces to adjust their properties based on environmental conditions, optimizing passive cooling and heating performance.